Hey, what's up, everyone? Seems like there's some people coming in. Let me just get everything adjusted so we can flow smoothly. We'll give it till a little after 10, everyone, just to make sure everyone gets in, logged in. If you don't mind, just say hey in the chat box just so I can kind of see who's in here. So, the chat box there to the right, just type hey just so we can see who's in here. So, I got Kenzie, I see Ellie. Can you hear me good, Ellen? If you guys hear random noises in the background, it's just um, one of many things. Could be our dog Rocket, could be Landon or London, or Miss IPOC. So if you hear random stuff, just try to ignore it. So I'm seeing where Kyle and Kenny said that a lot of people are restricted on school accounts. So that's again with this being new. I didn't know if it would restrict or not, but I think most people hopefully have a Google account that they can switch over. I'm seeing 11 people just to make sure. I just want to make sure I'm seeing everyone correctly. I'm showing Kenzie Kaiser, Ellen Nicholas, um, Jake Babst, Kenny Coons, Andy Babcock, Kyle Reed, Andrew Haynes, Tara Mua, whoever that is, Catherine Snyder, Molly, Ivan, there's Jesse, who in the world is BB, Mr. BB? Bella. Oh boy. Jared, why does your name have smokeless tobacco in it? Are you serious? Am I missing someone's name on here? Okay, I think that's everybody that is here. There's Jamie. What's up, Jamie? All right, let's do a quick test and then we'll get to the lesson today. This is the first one, so it goes a little bit slower in terms of, everyone getting logged on, everything happening. So if you can hear and see everything, if you can see it and hear it, go ahead and give me a smiley face emoji or something like that so we can make sure everyone is hearing and everyone is seeing everything good. Hey, who's HJ? Hello. Vandy's in the house. Hey, Jake Babs, the reason it's blurry is because it's your internet service. Don't be hating on the quality of the video. The reason I want to make sure I got everyone's name, I'm going to give you guys some extra credit points for being here at the live stream today. So I'm going to throw some extra credit points on your grade for being here at the live stream. Let's go ahead and just jump in this because I don't want to waste too much time. Okay, so looking here at lesson 4.3 notes, multiplying and dividing rational expressions. So if we, all right, I see you, Taylor. So if we think back to lesson 4.1 and 4.2 notes, that was the lessons over vertical asymptotes. If you can remember, that's when we learned about the rational function graph. That's when we learned about the whole, the graphs that look like this. And there could be holes, and there could be horizontal asymptotes, vertical asymptotes. And that was all about graphing rational functions. So today we stick with rational functions, but we're doing something a little bit different. We are multiplying and dividing rational expressions. So in the process of multiplying and dividing rational expressions, we're going to have some steps, okay? So the first thing we're going to do is learn how to simplify these problems. So to simplify, sorry about that. So to simplify, in order to simplify, our first step is to factor top and bottom. And then the second step to simplify would just be to cancel like terms or expressions. Okay. So some of you may say, well hold on, Mr. Alpot. Can we just go ahead and cancel like m squared and m squared here? Can I just go ahead and just mark those two off? And the short answer is this. No, you can't, because this right here is attached with subtraction to something else. So you cannot cancel those. Now, if this was multiplying this, then you could cancel. But since it's not multiplying, you just cannot cancel the m squared and the m squared. So you have to simplify it. So what that looks like is this. Your first step you're going to do is to factor the top and the bottom. So can I factor 9m squared? I cannot, because it's a monomial. So I can just kind of write that down. 9m squared. And then I write that over. Now I factor the bottom. What can I factor out of 6m squared minus 6m? 6m. So if I factor a 6m out of the denominator, 6m squared minus 6m, I'm going to get this, and then 6m out of 6m squared, I'm left with 1m, and then negative 6m, if I factor a 6m out of that, I'm left with minus 1. Now notice what just happened. We took this from being a subtraction problem to now bringing this out here so it's multiplying. So notice this 6m and this expression m minus 1 is multiplying. So therefore, I can now cancel or simplify this top and this 6m. So what will go into 6 and 9? 3. 3 goes into 9 3 times, and 3 goes into 6 2 times. Then I can cancel my m's. I have an m squared up here. Now keep in mind that m squared is really just m times m. So imagine this being written out as m times m. If that was the case, then I can cancel this m, and there's really technically 2 m's right here. So I can just like mark this 2 off because now there's just 1 m. And that would, and again, let me, since we're on a live video and I'm not there in front of you, let me kind of show you. This would look like this. If I had m squared over m, that really looks like m times m over m. So I cancel that, and I'm just left with that 1m. And that's what happens when we cross that 2 off, is it basically we just have 1m left. Okay, so then from here, I'm just going to write down what I have left. And what I have left is this. In the numerator, I have 3m. So I'm going to write 3m all over. And what's left right here is a 2. 2 times m minus 1. This right here, now I don't have, some of you may say, well, do you distribute that back in? And I'm going to say no, because when we simplify this, this is what we have as our final answer. So that right there is the simplified version of this right here, this expression. Okay. So, but notice that the instruction says simplify each. Okay, we've done that. We have simplified this right here. Now we need to state the excluded values. Now, an excluded value is what makes the denominator zero. Okay. So in order to find excluded values, you are going to simply do one thing. Set the denominator equal to 0 and solve. Okay. So let's go back over to our problem and let's do that. So my denominator is 6m squared minus 6m. And I just set that equal to 0. Okay. So with this right here, we can't solve that by adding 6m, dividing by 6, and then getting the m's. It won't work that way. This is a quadratic equation. So what you need to be thinking is this one thing. I got to factor this, which we really already done that. So let's factor it. So if I can factor a 6m out. And I am left with m. If I pull a 6m out of 6m squared, I'm left with an m. And if I pull a negative 6m, or if I pull a 6m out of negative 6m, I'm left with minus 1. And I just set that equal to 0. Now, the zero product property says if this times this is equal to 0, then you set this equal to 0 and the other one equal to 0. And then I have divide both sides by 6. When 0 is on top, it's equal to 0. And I add 1 here. And m is equal to 1. So my excluded values are 0 and 1. And you may say, well, what does that mean? What does that excluded value mean? And it just simply means these two numbers, if you plug them back into the denominators, back into the m of the denominator, it will make the denominator 0. And as we talked about last week, or the week before, whenever it was that we talked, the denominator can never be 0 in math. So if I was to plug 0 back in, 6 times 0 squared minus 6 times 0 is 0. You cannot have 0 in the denominator. If I plug a 1 back in, 6 times 1 squared is 6, minus 6 times 1 is 6. 6 minus 6 is 0. Both of these numbers make the denominator 0, so therefore they're excluded from this expression. And that's number 1. Okay, let's do the same thing with number 2. So let's look at number 2. So number 2, here we go. First step, simplify. Factor the top and the bottom. I cannot factor the top because it's a monomial. So I'm just going to simply say, write that down, 6x. Bella, you said, why is there a 2? Oh, above this box, right? Okay, I think I know what you're talking about. Are you talking about this 2 right here, Bella? Just respond yes or no, Bella. Hey, so Bella, I think you're meaning this 2 above this box. It's just from where we simplified that 6, because 3 goes into 6 2 times. So that 2 just came from that right there when we simplified, and I just kind of wrote it straight together. Okay, going back over here. Good to have you with us, Karen. And I agree with Redmond Chu. I don't even know what PDS stands for, so I'm not even going to say that. But good to have you with us, Karen. We're not surprised that you come with some issues with your dogs and cats. Okay, so going back over here to number 2. So first step, we factor the top and bottom. So the top cannot be factored. So it's a monomial, so we just bring it down. Now let's factor the denominator. So I can pull a 3x out of that. When I pull a 3x out, I am left with 5x plus 3. Okay. Now, looking at this right here, okay, so we factor this because we just can't cancel that x and that x because it's attached with addition. But now looking at this, now since this is being multiplied, what we need to do is we can cancel this. So I can cancel the x and the x, and 3 will go into itself once. It'll go into 6 twice. So I am left with what's on top? 2 over, and then look, the 3x canceled to a 1, so I don't have to put that. The only thing I'm left with here is the 5x plus 3. And there's nothing I can do with that from there. So that is the simplified answer. All right. So then from there, I need to find the excluded values. So in order to find excluded values, set the denominator equal to 0. So when we set the denominator, 15x squared plus 9x equals 0. We set it equal to 0, and then we factor it. We factor this because of the squared makes it quadratic, so we know we factor them. Really, guys, you've already factored it here, so it should be a little bit. So if you factor it, it should be here. So when we factor this, we factor a 3x out, and I'm left with 5x plus 3 equals 0. And the zero product property says this: set both of these equal to 0. 3x, set this side equal to 0, and set this side equal to 0. Divide both sides by 3 here. When 0 is on top, we get x equals 0. Here, we are going to subtract 3 from both sides. Cancels there. I'm left with 5x equals negative 3. Then I divide both sides by 5 and get x is equal to negative 3/5. So my excluded is 0 and negative 3/5. Now you may be saying, okay, what does that mean? That means if you put either one of these numbers into our original denominator, it will make it 0, and that does not work in math. Making some sense today, I hope. Okay. Thank you to those that responded. Jumping down here to number 3. Okay, so just again, just trying to clear some stuff up within the the whole chat thing. So and I'm seeing some ideas coming. Some of you, yeah, your internet connection is going to be crucial here because this is a live feed. I'm connected into an Ethernet cord, so just to try to help with that connection. But you can always go back once we're done with the live stream, and you can watch it. You can even rewind it back a little bit if need be. Okay. So let's continue on. Number 3. So with number 3, simplify each and state the excluded values. In order to simplify this, what we're going to have to do is we're going to have to factor the top and bottom. All right. So let's factor r squared minus 7r plus 10. Well, since your leading coefficient is 1, we just want to say 1 times 10 is 10. What will multiply to be 10 but add to be negative 7? And that would be negative 5 and negative 2. Okay. So the numerator would be factored like this: r minus 5, r minus 2. And I just put that over, and now let's factor the bottom. Leading coefficients 1, multiply that times negative 5. What will multiply to be negative 5 but add to be negative 4? And that would be negative 5 and positive 1. One second while I try to explain this to Bella. Hey, so again, I don't know where Bella is, but I am watching I'm watching this on my phone as well, just to kind of make sure, just to see what you're seeing. And of course, the mirror effect kind of happens here. But Bella, if you can see this, if you rewind, you want to make sure you're at the live point. So you can come all the way back here and you can be watching it, but you want to make sure you're at the live point. Okay. Make sure you're all the way at the live point. Okay, so getting back to where we were, and hey, just be patient. I ask you to be patient the first day, while people get used to this. So, all right, so coming down here, negative 5 and plus 1. So that would be r minus 5 and r plus 1. So now we cancel what we can. So this cancels with this, and I'm left with r minus 2 over r plus 1. Now, some of you may be saying, well, can't I cancel this R with that R? And you cannot. Here's why: because it's attached with subtraction and addition. You cannot cancel top and bottom unless there is multiplication, unless it's being multiplied. With this being attached with 2 with a minus, you cannot cancel the R's. So therefore, this is the simplified version of it. Now we go to the exclusion, set the denominator equal to 0, r squared minus 4r minus 5. We set that equal to 0. And again, guys, this is a quadratic equation, so you have to factor it. Good, Bella. Good to have you with us. So r squared minus 4r minus 5. We've already factored it right here using this, so we just can use the same thing. R minus 5 and R plus 1 equals 0. That's the factored form of that. Hey, Taylor, I don't know if you're live with me, But the reason we can't simplify this right here is because this m is attached with this minus with that 1. It's a good question. I could see where you were saying like, hey, well, this is attached with that multiplication, but it's attached right here with subtraction. So therefore, we can't just cancel those two. Good question, though. Does that make sense, Taylor? Just give me a thumbs up or something if that kind of makes sense to you. Okay. So here now, r minus 5, we set both of those equal to 0, and r plus 1 is equal to 0. So therefore, add 5 to both sides, and we get r is equal to 5. Subtract 1 from both sides, and we get r is equal to -1. So my excluded values are 5 and -1. And what you may be saying, well, what in the world does that mean? That means if you were to plug those in to this r right here, it would make the denominator 0, which cannot happen in math. The denominator can never be 0. Number 4. Okay, same thing. Here, first step, to simplify this, we got to factor the numerator and the denominator. So let's factor the numerator. I can pull a 5 out. If I pull a 5 out of 5k minus 25, I'm going to get k hey, good question, Kyle. Sorry, I should have waited for questions. So Kyle asked a good question. He said, and he asked this earlier, and I knew we'd get to it. So Kyle said that like on number 1 and number 2, 0 was always excluded. But watch if I plug 0 in here, and this is not just for Kyle, but for everybody. If I plug 0 into that, 0 squared is 0, minus 4 times 0 is 0, 0 minus 0 is 0, but 0 minus 5 is -5. So therefore, it does not make the denominator 0. So an easy tip that you can always remember is if the denominator, if everything has variables, 0 is going to be an excluded value, because if you plug it in, it'll cancel. Same thing here. Both of these had a variable, but because this didn't have variable on 5, that's when we know that 0 is not going to be it. Same thing over here. If you plug 0 into this, because 25 doesn't have a variable, it's not 0 is not going to be an excluded value. So very good question. Okay, so going back to factoring the numerator, if I pull a 5 out of 5k, I'm left with k, and if I pull a 5 out of 25, I'm left with -5. I put that over, and then notice here, k squared minus 25. And some of you may be saying, how in the world do we factor that? And that is an identity. It's the difference of squares. So the difference of squares. So if I was to bring this to the side and say k squared minus 5 squared, and then someone type into the chat box what that answer would be. Use parentheses. Someone type that into chat box. What is that in factored form? Anybody? Look at my guy. Vandy, you're off by one thing. Look at Kenny in the house. Very good, Kenny. That's going to be k minus 5, k plus 5. Very good. Yeah, Vandy. Only that you just messed one of your signs up. So remember, it has to be both. So we have k squared minus 25 is k minus 5, k plus 5. Now, here's what happens. This cancels and this cancels because everything's multiplying now. And I'm left with this 5 over k plus 5. And I can't. Can someone tell me in the chat box why I can't cancel these two 5s? Because 5 is what? That would be correct, Kyle. Yeah, very good, Vandy. And I like that. Yeah, there you go. Hashtagging it, Bella. Hashtag attached. Attached. Good. And I think Kenny said it real good. Followed up by Maddie. It's attached by addition, so you cannot cancel those. That's why it's simplified. Very good. Look at you all today. Now, just to find the excluded values, you got to set the denominator equal to 0. And the only way to simplify this is by factoring because it has a square. So we know it's quadratic and we've already factored it. It's k minus 5 times k plus 5 is equal to 0. Set both of those equal to 0. K equals, if you add 5 there, that's 5. Subtract 5, subtract 5. K equals negative 5. You all may hear my dog barking in the back. The garbage man's rolling through the neighborhood. Excluded values would be 5 and negative 5. Okay, so that is simplifying those. We have 4 more problems on the back that we need to go to, but let me get some. Let me at least get some thumbs up or a smiley face or something showing that you guys are kind of following along with this. Give me something. Okay, cool. Let's jump to. I know some of you may be struggling just a little bit, just because I don't know if it's your internet or you're behind, or if it's just the style of teaching. We will try to I can connect with you, Bella and Karen, just to kind of help out a little bit within that. I can stay late and we can even do a video conference in on how to we can do a Zoom conference. I can reach out to you, Bella. Okay. Who's icon IK? Who's con IK? My boy Chris. Chris is in the house. Okay. Now, go into the backside now. So on the back side, we're dealing with multiplying. So on the front side, we dealt with just simplifying a rational expression. But now on the back side, we go to multiplying a rational expression. Okay? And the way you're going to multiply, okay, yeah, sounds good, Karen. So what we're going to do on the front side is, or excuse me, what we're going to do on the back side is essentially the same thing. We're just going to multiply these. So it's like we have fractions, but in the end, we're going to just multiply them together. So it's not as bad as what it looks to be. So with that being said, let's get started. So when you're multiplying these, okay, your first step in multiplying, I know I got a little blurry there, sorry. First step in multiplying is to factor everything. Okay, so when I say factor everything, I'm really talking about factor this numerator, this denominator, this numerator, that denominator. So factor all four things. All right. So when I factor the numerator of the left side, I can factor a 2x out. When I factor a 2x out, I am left with x plus 3. And I write that over. Now this x plus 3 cannot factor. So we just bring it down, x plus 3. It's there's nothing I can pull out of it besides 1, so I just leave it alone. And then times, I can't factor anything out of x minus 4, so I just bring that down, x minus 4. They don't have anything alike, so I cannot factor it. And then same thing with this monomial here, 3x squared. There is nothing alike, so I cannot factor it. Now from here, what I'm going to do after I factor is my second step is to cancel what I can. So I'm going to cancel x plus 3 and x plus 3. Since this is by itself and this is up here being multiplied, I can cancel that. I cannot cancel anything over here, so the way that would look is like this. 2x over 1 times x minus 4 over 3x squared. Now, I just do what I did a long time ago when you're, for instance, if you were multiplying 1/2 times 2/3, you just multiply numerators and denominators. So 1 times 2 is 2, 2 times 3 is 6. Okay, so same thing here. I'm going to say 2x times x minus 4 and 1 times 3x squared. So that would look like this, 2x, and how do we show multiplication? With parentheses, times x minus 4 all over 3x squared. Now, some of you may be saying, well, wouldn't you distribute this in? Now, keep in mind, if I distributed this in really what I could do once I distribute it is to factor it right back out. So there's no reason when we put these together, like with multiplication, we'll just put them together with these parentheses. Now I can cancel one more thing. Okay. Can't mess with anything right here with this x minus 4 because I'd have to have a x minus 4 on the bottom to cancel that. But notice this x right here and this x squared here. So I can cancel this x right here with, keep in mind, x squared. Keep in mind that x squared is x times x with one of these x's here. So I can just mark out the 2, and that's what I have there. And then I just simply have this as my final answer. 2 times the quantity of x minus 4 over 3x. Hey, Molly, I assume you're talking about these fractions right here. 1/2 times 2/3 equals 2/6. I was just showing an example of what you did to multiply, like back in middle school when you multiplied fractions, you just multiplied the numerator and the denominators. So I was just showing you that you multiply this 2x times x minus 4 and 1 times 3x squared. You just bring them together just like you would 1/2 times 2/3. So again, as Jake is saying, this is just simply an example. So that is my final answer for that. But keep in mind, I have to find exclusions. Okay. Now, on the front side, we simply had one exclude. We just had one denominator. So we just had, one thing that we to look at in terms of exclusion. But here we have two exclusions. Here we have two denominators. So on the front side, we just set the denominator equal to 0. Now we have to set this denominator and this denominator equal to 0. So we say x plus 3 is equal to 0, and 3x squared equals 0. So then I just subtract 3 from both sides, and I get x equals -3. And I divide by 3 on both sides here. When 0 is on top, your answer is 0. Take the square root of both sides. That cancels, and the square root of 0, sorry about that, square root of 0 is equal to 0. So my excluded values are -3 and 0. And hey guys, I know that we're at like an hour of live time, but keep in mind, we're only doing this twice a week. So I was anticipating this taking a little bit longer than like a normal class would. And that's simply because all the, the technical issues we got to work through. But these are probably going to typically last a little bit more than an hour. Okay. And again, we're only doing, I think maybe we're only doing 2 this week. So that's, you are getting your normal kind of time with me. So just want to make that. Give me a thumbs up. Give me a smiley face, something with 5. Give me like, okay, we're seeing this. See Taylor, Maddie, Bella don't even know how to log on to YouTube. Thank you, Kenny. Good, Tara, Jamie, Catherine, yeah. Ellen, look at Ellen in the house. Jamie, Dozier, good. Jesse, good. Yeah, I think Karen, this week's it's at 11, but next week it may switch up just a little bit. But I'll give you the schedule on Sunday to just so you kind of know. All right, let's continue on. Jumping over here to number 6. Okay, same thing. Factor everything. Okay, factor all 4 of these right here. So let's factor the numerator right here. What can I pull out of 2a cubed minus 4a squared? Someone shoot that in the chat box. What can I factor out of 2a cubed minus 4a squared? Yeah, good, Kenny. 2a, yeah, so 2a, and then just do carrot top squared, right? So 2a squared. There we go. So 2a squared. 2a squared. And then I'm left with, what am I left with on the inside? Someone shoot what I'm left with on the inside. Should be a minus 2. A minus 2. If I pull a 2a out of 2a squared, I'm left with a. If I pull a 2a squared out of 4a squared, I'm just left with negative 2. And now I put that over. Now look at this, a squared plus 2a minus 8. So here's what I need. What will multiply to be negative 8, but add to be positive 2? And that's going to be negative 2 and positive 4. So that leads me to a minus 2, a plus 4. Now, don't forget about this right side over here. Neither one of these can factor because they're monomials. So we just bring them down 5 over 2a squared. Okay, now let's cancel what we can. So watch this. I can cancel this a minus 2 and a minus 2. Now, some of you all can recall that we've done cross simplification, that you can simplify the numerator and bottom when they're the same, but I can also cross simplify. I can cancel 2a squared and 2a squared. And you may say, well, why can you do that? And think about, once we brought that together, we would be able to cancel it. So you can just cross times 5 all over 2a squared times a plus 4. And then that can show you there as well that you could cancel those two because they're being multiplied. Kenny, I was just showing that you can cancel these here like this, or you could just bring this down. You could, if you bring those two together, they cancel. But all in all, you're still going to get the same answer as 5 over a plus 4. So again, if I cover this up right here, if I cover this up, and I cancel 2a squared and 2a squared by cross simplifying, I have what I have left would just be 5 times 1, which is 5, and a plus 4 times 1, which is a plus 4, giving me my answer of 5 over a plus 4. Sorry about that. But I was just showing the mathematical reason why you can cross simplify like that. Because if you did bring those two together, the top and the bottom together, they would just cancel anyway because they're on the top and bottom, giving us the same answer. So just showing you really, and it's probably not the best way to do this on video, showing you two different ways, but just trying to have you to understand it a little bit. Okay, what's up, Vic? All right, now let's find the excluded values. So it's excluded values. Remember, with excluded values, you set the denominator equal to 0 when you're multiplying. But we don't just have one denominator, we have two, so we have to set them both equal to 0. So a squared plus 2a minus 8 equals 0, and 2a squared equals 0. Set both denominators equal to 0. And then here, again, we've already factored that. The way you would solve this set equal to 0 is you'd factor, and we've already factored it. Correct, Vic, yes. A minus 2 and a plus 4 equals 0. And then just setting both of those equal to 0. And that would be a, add 2 to both sides. A equals 2. And here subtract 4 from both sides. Getting a equals negative 4. And then don't forget about this other denominator. You got to divide it by 2. A squared is equal to, when 0 is on top, your answer is 0. Square root both sides. A equals 0. So my excluded is 0, 2, negative 4. Sorry about that. Tara, yes, 3 excluded values. And order does not matter. For the excluded values, Taylor. Okay? Are we okay with that? Give me thumbs up, smiley face, at least that you're comprehending a little. Yes, Jake, I can. I assume a lot of people's about to do thumbs up, so we'll give them a second. Okay, so Jake asked a really good question. He said, why is 0 excluded? So on the front side, what we did was we set the denominator equal to 0. But over here, when you're multiplying, Jake, you have to set this denominator right here equal to 0, and this one equal to 0. So when we set this one equal to 0, the first denominator, we got 2 and negative 4. But when you set the second one equal to 0, we get a is equal to 0. So divide both sides by 2, take the square root of both sides, and you get a is equal to 0. So again, if you ask yourself, well, what does that mean? Here's exactly what that means. If you plug 0 into this, it's going to make this side 0, which will make that side 0 when you multiply. If you plug a 2 into any of the a's here, it's going to make this side 0. Same with negative 4. And then the whole problem equals the denominator the denominator has it as 0. Yes, Vandy, we did that to the number 5 as well. We did x plus 3 equals 0. This x plus 3 here, it's right here. And 3x squared is here, setting that equal to 0. That is correct, Vic. Excluded only deals with denominators. Yep. Okay. Now, if you look on the front side, we just set this one. Here's like number 4. We just set this first one equal to 0 because we only had 1. So we set that equal to 0 and we found it. But on the back side, we have 2 denominators. So we set both of those equal to 0. Okay? All right. So going to the last 2 problems, then we're done. Hey, Molly, I'm about to do an example just to refresh your guys' memory on dividing. So this is just an example of dividing, okay? So if you had 1/2 divided by 2/3. Molly, this is an example. We bring this down, we change the sign, and we do the reciprocal. Very good, Maddie. Keep, change, flip. So you're doing the same thing, but you don't just have numbers, you have expressions. So jump in here to number 7. Okay, looking at number 7. So here's what you need to do first. Okay, let's go ahead and keep the first one, change the sign, and flip the second one. That's what we're going to do first. So here we go. V squared minus 4. We're keeping the first one. Over V minus 3. Change the sign to multiplication, and then flip this one. V minus 3 over V plus 2. Okay? Now, V squared minus 4 over V minus 3 times V minus 3 over V plus 2. Now, can someone tell me what we just made this? What kind of problem did we just make this? We made it a what kind of problem? Very good, Vic. A multiplication problem. Okay, good, Kenny. A multiplication problem. So what does that mean? We're going to do what we've done up here. We're going to follow those same steps that we did up here. So once you get it to multiplying, factor everything, cancel. Okay, so here we go. Let's factor everything. Hey, shoot in the chat box real quick. How many of these out of the 4 can be factored? How many out of the 4 can be factored? Good, Taylor Rice. Good, Vic. Good, Maddie. There you guys go. Good. Only one thing can be factored out of this, and it's this right here. All right, Jake. If you'd quit talking about people's names, you would know what happened. So, Jake, we kept the first one. We changed the sign, and we flipped the second one. Keep, change, flip. You good, Jake? Okay, very good, Jake. So here we go. V squared minus 4. Can someone tell me what the name of that is? What is the name of this? It's a difference of... Yeah, good, Kyle. It is an identity. It's difference of squares. Good. There we go. Now we're flowing there. All right. So we have here, actually, someone tell me what it would be. Someone in the chat, tell me what it'd be with parentheses. There's not a limit on exclusion, Karen. All right, very good. I see those coming in. So it's V, because again, V squared minus 4 would go to V squared minus 2 squared, which is V plus 2, V minus 2. So here we go. This is V plus 2 times V minus 2 all over V minus 3 times V minus 3 over V plus 2. And those of you that said there's only one thing to factor, that's correct. Good question, Vandy. It doesn't matter. You can put the plus or the minus first. Okay, so then we can now let's start canceling some stuff. Okay, so notice here, again, keep in mind that cross simplify. I can cross simplify, so I can cross simplify V minus 3 and V minus 3. Yes, you can, Molly. And then I can also cancel what? V plus 2 and V plus 2. So then my final answer is just simply V minus 2. Okay. Now, a difference here with multiplication and division, okay, is when you go find your excluded values, when you go and find your excluded values, you know how with multiplication we found it for the two bottom ones? But with division, when it's a division problem, you have to find it for three things. For this, that denominator, this denominator, and this numerator. You have to set all three equal to 0. Okay. So, and you may be saying, well, why is that the case? Because we flip this one right here. So the denominators are simple because they're in the denominator. But because we flip this in multiplication, we need to get all three of these. Because, and Ellie, I don't know if you just heard me, but when we do keep, change, flip, the numerator becomes the denominator. Okay, so here's what that looks like. We're going to say v plus 2 equals 0. V minus 3 is equal to 0. And just because we want to keep it a good habit, you want to do all three. Now, I know those two are the same, okay? But just out of habit, what we want to do is we want to set all three equal to 0. Yeah, Vandy, I got you. Minus 2, v equals negative 2 there. Plus 3, v equals 3. And then obviously same thing there, plus 3, v equals 3. So my excluded values are negative 2 and 3. But Vic, I see where you're going with that. That 3 is 2 of them, but you don't have to say that. You can just say negative 2 and 3. We're only concerned with multiplicity, Vic, when we have a turn, when we're graphing it and we have a turn in the graph. But since this is not a function because it's not f of x is equal to a number, we just simply say negative 2 and 3. Okay. Very good. Last one, guys. Last one, then we're done. Okay. So here we go. Remember, first step with division, when it's division, guys, we're going to keep, change, flip. 15n cubed minus 12n squared all over 3n squared. And then change the sign of multiplication and flip this. 5n squared over 10n minus 8. Hey, Jake, how did this become a multiplication problem? Type your answer in the chat box, just making sure you're on the same page. Good, Jake. Good, Jake. Okay, so then from here, let's factor everything. So I can factor a 3n squared. Yes, keep, change, flip is for division of fractions. So I can factor out 3n squared here. And I'm left with 5n minus 4. And I put that over 3n squared cannot be factored. 5n squared cannot be factored. And I put that over 10n minus 8 can be factored by pulling a 2 out. If you pull a 2 out, you're left with 5n minus 4. Okay, so now we just start canceling. Okay, so watch this. Here we go. 3n squared and 3n squared. Five n or 5n minus 4 and this 5n minus 4. And then what am I left with? What am I left with here? I'm left with 5n squared over 2. Hey, Taylor, talking to Taylor due to Taylor's comment. Hey, Taylor, here's what you ask yourself. What can I factor out of 15 and 12? I can pull a 3 out of that. And then what can I factor out of n cubed and n squared? N squared. And then once I factor a 3n squared out, 15 divided by 3 is 5. N cubed divided by n squared is just n. And then negative 12 divided by 3 is 4, or excuse me, negative 4, and n squared over n squared just cancels. Does that help, Taylor? Give me a okay or thumbs up. So, Taylor, just to kind of, if I bring that over here, and I say, if I say 15n, let me just write on this paper, 15n cubed minus 12n squared. Okay. So really, what we're really doing here is when you factor, what can come, what's the least common of 15 and 12? Well, 2 won't go into 15, but 3 will. 3 will go into 12. And then, so we know that that's 3, and then n squared. And then what we're left with is really, when you're factoring, you're really just kind of dividing that out. That's where I might have said we're dividing it out. So 15 divided by 3 is 5. N squared divided by n cubed divided by n squared is really n. And then minus 4, and n squared over n squared would just be that. So I don't know if you heard me say like this over that is that, but that's how we would factor, okay? But no, you're not doing any division, though, to kind of answer that question. Okay? So last thing, we need to set it equal to, set 3 things equal to 0. Both the denominators and the numerator of the right-hand side, because we flip it on keep, change, flip. Okay. So we say 3n squared is equal to 0. 5n squared is equal to 0. And 10n minus 8 is equal to 0. Divide both sides by 3 here. I got n squared is equal to 0. Take the square root of both sides. That cancels. N is equal to 0. Divide by both sides by 5 here. That cancels. N squared is equal to 0. Take the square root of both sides. N is equal to 0. Here, add 8 to both sides. You get 10n is equal to 8. Divide 10 on both sides, and you get n is equal to 4/5 when you simplify that down. So my excluded is 0 and 4/5. Okay? That is that notes. Okay? So give me thumbs up if you're feeling at least halfway good. Good, Vandy. Good, Kenny. Good, Jamie. Good, Tara. Good, Ellen. Good, Kenzie, Kaiser, Jamie Dozier, Catherine, Kyle, Jesse, Chris, Molly, Andy, Andrew, Jake. Good. Good, Taylor. Okay, so Vandy asked for me to explain the turn-in process. Okay, you are not turning anything into me, okay, until you come back from spring break. All right. So we just did 4.3 notes. Okay, this is 4.3 notes. I expect you now, today, tomorrow, sometime, to do 4.3 homework, following the notes we just did. Go back and watch the video if you need to. Okay. You are not turning anything in. You don't have to take a picture. You don't have to send it in. Here's what I basically want. I want everything done when we come back on April 14th. If for some reason we do not come back on April 14th, then I will make an arrangement for you to turn everything in. But until we really understand what that, if we don't come back or if we do, then let's just keep it this way. So you're not turning anything in. You are just here, and you're just here. Make sure you're working through it every day, and we'll go that way. We will have a quiz, and I'll give you more. Tara, we will have a quiz/test, and that'll be on Canvas, and I'll explain it once we get there. Okay. Yes, Molly, you can unstaple everything from your packet. That's completely fine. But I need you guys to be mature enough to handle this. So when April 13th comes around and you're like, oh man, we're going back to school tomorrow, that you don't have this full packet blank. Okay. Because I'm going to give you points for the notes and the homework. Okay. I'm going to give you points for the notes and the homework. Any other questions of me? Thank you, Taylor. I think this way can, I think it can continue to work well. But hey, when we have 25 people in here, that's huge. That's big time. So I give you guys props for being here. I encourage you to be here every single time we're live. Maddie, you'll see in the schedule when the test / quiz is. Correct, Molly. I will actually jump on early on Thursday. So if you have any questions, I can I'll take some questions Thursday over the homework if you have any questions, and I'd be happy to work a problem if you want me to work a problem. So yeah, you guys are free, and I like to take questions. So if you have any other questions, let me know, because people that come on later and check this live stream out, they can see that as well. If here is the schedule, I don't know how well you all can see that or not, but the top line is Algebra 2. So here's your schedule for the rest of the week. So on Thursday, you have YouTube Live at 11 a.m. over 4.4 notes. And then I'm on YouTube Live every Friday at 10:30 for any kind of questions that you have. And then if you guys are done, no more questions of me, hey, please knock that 4.3 homework out. Send me questions on Canvases if you have any questions on that. And then you guys can start falling off. If you have questions and you want to stay, like, if you want to like wait for everybody to leave, feel free to do that. And I'll kind of keep the live stream going for a few more minutes. Hope you guys are doing well, though. Hope everybody's, staying quarantined and doing great. Miss you guys and hate that we can't be in class together, but, it is what it is. You hate to see it. Jake, it'll fluctuate. It will fluctuate kind of back and forth because I have other classes that I'm doing live with as well. Not just this class. I have two other classes I'm doing it with. So, so it may not be every Tuesday and Thursday. I tried to keep them the same. So just, know that it should be around there. Bella, why are you crying? I'll stay on until 1 hour and 40 minutes, and then I'll end the stream. So if you have any questions, let me know. Thank you, Jesse. Yes, thank you. I would slay you guys at Fortnite. You all don't want the smoke.